Hi, this tutorial covers either or probability for overlapping events. All right, let's start with a situation here. So suppose a freshman from a local college is selected at random. Let event A be the event that a freshman takes intro to statistics. Let event B equal the freshman takes intro to psychology. And then we'll let probability of A equal 0.18, probability of B equal 0.21. So can we determine A or B? Okay, so remember that the special addition rule says that the probability of A or B equals the probability of A plus the probability of B. But now remember that only works if the two events are non-overlapping. So let's consider these two events, event A and B. So can there be common outcomes to both event A and event B? Can a freshman take both intro to statistics and intro to psychology? And generally, yes. There might be outcomes that are common to both events. So this 18% might include people that are enrolled in both courses. Okay, this 21% might include people from um, both courses. So if we were just to add these two probabilities up, we're going to end up double counting the people that are enrolled in both courses. Okay, so at this point, no, we cannot determine A or B. Okay, all right, so we need a new rule. So the special addition rule, that's the one we just went over. If events A and B are non-overlapping, then the probability of A or B equals the probability of A plus the probability of B. Okay, now the general addition rule, notice, does not have a condition. Okay, this can be used in all cases. So the probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. Okay, so if we think about A and B, that's going to include the probability of this is going to give you the probability of a student taking both classes, both statistics and psychology. So if those students are included in both A and B, we need to subtract off A and B so that those people are not double counted. Okay, now also remember that if events are non-overlapping, the probability of A and B is equal to 0. So if this equals 0, the general addition rule becomes the special addition rule, because if they're non-overlapping, A and B is equal to 0. Okay, so if we think back to the example again, so why couldn't we calculate A or B? Because we didn't know what's the probability of a student taking both classes. Okay, so what we're going to do now is suppose that A and B equals 0.08. So there's an 8% chance that students will take both of the two classes. All right, so I think it's helpful to visualize these probabilities in a Venn diagram. So let's draw a Venn diagram here. Okay, so what we're going to need is a circle for intro to statistics, which we'll call that A, and a circle for intro to psychology. Since there is an overlap, I'm going to draw the circles overlapping. So this is going to be psychology. We're going to put the 0.08 in the overlapping region. So that's 0.08. Now A, this region here, are the students that take intro to statistics but do not take intro to psychology. So remember that altogether 18% take statistics. So that means 10%, only 10% take statistics but not psychology. Okay, then for only psychology and not statistics, that's going to be 13.13 or 13%, because these two then will now add up to that 21%. Okay, now if we want to figure out what's the probability that that a student takes neither psychology nor statistics, all we need to do is add up the three numbers that are already in our Venn diagram. So that's 31%, and subtract that from 1 to get 0.69, so 69%. Okay, so Now, if we want the probability of A or B, there's really two ways to do it. We can just add up these three outcomes, or we can use our new rule, the general addition rule. So we knew that these added up to 0.31, so let's confirm that using the rule. So we'll take the probability of statistics plus the probability of psychology minus the probability of both. So we're going to have 0.18 plus 0.21 minus 0.08. And to do that, let's just do those in the calculator. Oops. Okay, and that does end up giving us 0.31. So there is a 31% chance that a randomly selected student will take either stats or psychology or both. Okay, so let's do one more example. So I usually like 70% of the movies I see. My wife likes 80% of the movies she sees. We both like 50% of the movies we both see. So we'll both like, so if we see it together, there'll be a 50% chance that both of us like the movie. So if we notate these probabilities, let's call this the probability of A, where event A is the event that I like a movie. Let's let the 80% be event, or the probability of B. So B is the probability that my wife will like it, and 50% will be the probability of A and B. Okay, so if my wife and I see a movie, what's the probability that my wife or I will like the movie? So here we're looking for now the probability of A or B. Okay, and they are overlapping events because there are movies that we both like, so we'll use the general addition rule, which says the probability of A plus the probability of B minus the probability of A and B will equal the probability of A or B. Okay, so if we do that, this is going to be 0.7 plus 0.8 minus 0.5, and use the calculator. That's going to give me 1. Okay, so it actually worked out pretty nicely here. There is a 100% chance that that either my wife likes it or I like it, or we both like it. So since that was 1, there's a 100% chance of that occurring. So yeah, so that is the tutorial on either or probability for overlapping events. Thanks for watching.